Hello. Today, Science Workshop comes from the jungle. Well, it's not actually the jungle. It's the Palm House at Kew Gardens in London. And I'm looking for a very special plant that started a revolution in transport about 100 years ago. Ah, here it is. Hevea brasiliensis. That's Latin. All plants and animals are given scientific names in Latin. Hevea brasiliensis is a rubber tree. From its sap, called latex, that we develop all our natural rubber. Now, trees like this were first grown in Brazil. But in 1876, because of its remarkable sap, seeds were smuggled out of Brazil and were first nurtured into seedlings here at Kew Gardens. And from here, they were sent all over the world, to places like Malaya, where vast plantations were developed to harvest the precious latex. Every 2 or 3 days, a tree is tapped. When a thin sliver of bark is carefully cut away, a white milky fluid runs out and is collected in a bowl. This is latex. It's taken 2 or 3 hours for this amount of latex to run out ready to be collected.
Now, some of you may have wondered about rubber plants that you see in people's homes. Well, you will get latex from a plant like this, but not very much, and not very good quality. Certainly not as much as this, which is the amount of latex a rubber planter would get from one tree in one day. Latex doesn't look very much like finished rubber. There's lots of ways to change latex into rubber, but one of the easiest is this. We've got some latex, vinegar, and water. Drop of latex in the vinegar. Squeeze it around for a minute. Whoops. There we go. Rinse it off in the water. Dry it. Here we are. Well, not very good quality, but it is rubber. And the vinegar has turned the latex from a liquid into a solid. Here's something made of latex that you'll probably all recognize. First, the latex for rubber gloves is thoroughly mixed with a pink dye. These hand-shaped molds are then dipped into the mixture. The next stage is to roll over the cuffs, and here you can see how it's done. Before the gloves are dipped for a second time, they're checked. This second dipping is for the inside layer. The gloves are turned the right way out when they're taken off the mold. The next stage is very important. The gloves are cooked in ovens like big tumbler dryers. Cooking is an essential part of all rubber making. We'll see why in a minute. Next, the gloves are checked to make sure there are no faults. Then they're put in pairs and go off to be packed for the shops. Well, why do gloves have to be cooked? Well, this is a cooked glove. See what happens. If you stretch it, it returns to its original shape. And with quite a lot of force. It's elastic. So, the gloves are cooked to make them elastic. But it's not just the heat that does it. The latex is mixed with a yellow powdery substance called sulfur. And it's the sulfur and the heat that makes the gloves elastic. The process is called vulcanizing. The rubber has to be vulcanized to make it useful and elastic.
Tennis balls are made of rubber, and they have to stand up to a lot of stretching and bouncing. These are lumps of specially treated latex mixed with sulfur, and all exactly the same size. One lump is put into each of these hollow molds, and then the mold is closed. The machine presses each lump into the shape of half a tennis ball. Two at a time, the halves are put into holders on this machine, which first rubs the edges to make them rough, and then dips the rubbed edges into a latex glue. Now the halves are positioned in molds in the bottom and in the top of a special oven. When the oven is closed, the top and the bottom molds come together. The latex glue helps to stick the two halves together, and the rubber balls are cooked. They are vulcanized. This is the ball after it's been vulcanized. It doesn't look much like a tennis ball yet, though. It's got to be covered in a hard-wearing felt. Now, this is a felt. Now, the problem for the manufacturers is to get the right shape of felt to cover that ball. I wonder if a circle will fit it. Let's try. A bit like that. I need a lot of folds this way. And that's covered it. It's hardly good enough for a tennis ball. So the manufacturers have come up with these shapes. Now, at first glance, they don't really look as if they're going to fit. But that piece goes over the join, and that piece goes in the gap. First, the vulcanized balls are covered with a layer of latex glue. Each ball is then held in position. Then the first piece of felt is fed in and around it. The second piece of felt is put on by hand. When both pieces of felt are in position, the balls go through another oven to vulcanize the latex glue. It still has to be trimmed, and the pile has to be fluffed up before it's a finished ball. Then the final stage, samples of the finished balls are tested. This machine bounce tests tennis balls. Each ball is dropped from a fixed height, and it must bounce up between 53 and 58 on the scale, and the height of each bounce is recorded. To get a correct reading, the tester uses the mirror to line up the bottom of the ball with its reflection. That's 57. This machine hits tennis balls over and over again for up to 6 hours. It's a sort of endurance test for tennis balls. In slow motion, the balls drop down and are struck by the metal racket onto a board covered in a rough cloth. They bounce off and back into the machine, and so go round and round, over and over again. This test really finds out how well tennis balls will stand up to the sort of treatment that they would get from the top players.
In the late 19th century, the hobby horse, the bone shaker and the penny farthing were common enough sights. But riding a bicycle in those days on solid rubber tires wasn't a very comfortable experience. But one man was determined to beat the bumps. His name, John Boyd Dunlop, and in 1880 he invented his own tire, a rubber tube held onto a wheel by canvas and filled with air from a football pump. Outside, Dunlop carried out a test. a solid rubber tyre from his son's tricycle against his own. The new tyre rode easily over the bumps, and for Dunlop the test was successful. The next step was to fit these tyres to his son's tricycle and find out how they would stand up in practice. Dunlop's young son John became the first to ride a bicycle on air-filled tyres. At the Queen's College Sports in Belfast, Dunlop's tyres were used for the first time in a race. The rider was William Hume, a famous racing cyclist. There was a great deal of interest in the new tyres, but no one really believed that Hume had a chance. It was all a bit of a joke. But Dunlop wasn't at all put out. "Wait till it's over," he said.
They're off, and it's a perfect start with the best of Ireland cyclists getting away in fine style. They're neck and neck. Hume's no more behind than the others are in front. It's terrific. Lap after lap, and still the new tyres are standing up to the pace. It's getting very tense now, but on the last lap, there's still no sign of Hume making the break. And there he goes. There goes Hume, piling on the pressure. The crowd are going mad with excitement. And Hume goes ahead. But can he hold it? Is he going to make it? And he's done it! Hume has won. No one is laughing now. It's congratulations all round.
You ever had a flat tyre? Tyre without any air isn't very elastic. Look at the back one. Bicycle tyres, or car or lorry tyres, have to put up with a lot of bumps and bangs as they go along the road. They're constantly being stretched and squeezed. So the manufacturers have to make sure that the rubber they use is strong enough to put up with this constant wear and tear. This machine tests how many times a sample of rubber can be squashed and then recover its shape. That change in the sound means that the rubber has finally broken down. And there you can see what's happened. In this test, the rubber is stretched and then allowed to recover its shape over and over again. All the rubber samples are cut to the same size and shape to make sure the tests are fair. And in this test, the sample is going to be stretched until it snaps. The machine is controlled by a computer. Everything is recorded automatically. The samples have to pass these and many other laboratory tests before the rubber can be used to make tyres.
We all know what tyres look like on the outside, but have you ever wondered how they're made up? Well, here's a piece cut out of an old tyre. The inside has a thin rubber lining. The next layer is a fabric layer, and the threads run radially. That's why it's called a radial tyre. Next are 2 layers of woven steel for strength. And then there's a thick rubber layer with a tread pattern, which is very important for driving in the rain. The Science Workshop camera team went to find out how tyres are made. It takes only 2 or 3 minutes to put all the layers of a tyre together. The men who do this work are very skillful. With all the layers assembled, it begins to look like a tyre and it's ready for the mould. Inside the mould, the rubber is pressed into shape and cooked. It's vulcanized. This takes about 15 minutes. Once it's had time to cool down, each tyre is checked by feel and by eye. And every tyre is X-rayed. The X-ray machine will show up any faults inside the tyre. Now, as well as the checks that there are for all tyres, some tyres are chosen to go through a series of special tests. This is a steering test. All the tests are controlled by computer. This tests what happens on bumpy roads. As well as controlling the tests, the computer also keeps very accurate records which are used by the scientists. This is another very important test. The tyre is run against a revolving drum. The pressure in the tyre is then reduced to below the correct level. Now watch what happens to the tyre as the speed is increased. Finally, tyres are tested on cars at the special testing track. And to show you what's happening to the tyre during the test, the Science Workshop camera team fixed a camera onto the front of a test car.
All right now? That was okay, John. I'll put you ready.